Okay, here we've got another tricky geometry algebra problem that results in a quadratic which we then have to solve. Now we've got a playground as marked, width x, length 3x. And the playground's being extended. We've got 10 meters being added to the width, so this is plus 10. And we've got 20 meters being added to the length, so this is plus 20. The area of the larger playground is double the area of the original playground. So that's the fact which links areas and therefore equations. So let's compare original extended and compare the area. So the area of the original was x by 3x. So the original is 3x squared. And this area is going to be x plus 10 multiplied by 3x plus 20. So now let's deal with that business that the larger playground is double the area of the original and see if we can pop that into algebraic terms. The area of the larger playground, which is this guy here, so we can write him down, and the question tells us that this is double the area of the original. So this is double this guy. So this is 6x squared. We're going to multiply this out in a way that's now very familiar to you and see what we get. This will give us 3x squared, the underneaths. We've got 30x here and another 20x here. So this is plus 50x. And the numbers 10 times 20, 200. And this is equal to 6x squared. Notice that the 3x squared is positive, so everything is going to go onto this side, but I'm going to write this side first, if you know what I mean. This side's going to become the left-hand side. We can simplify the x squared terms in that we've got 3 here and 6 here. We can take 3 from both sides, giving us now just 3x squared. These have now both shifted sides, so we're going to move both of them onto the right-hand side. They become negative. And we get negative 50x, take away 200, must equal 0. And happily, that's the same quadratic equation that's in the question. So we come to part B, and we've got to calculate the original area of the playground. So we need to calculate this up here, which means we need to find x, which means we need to solve this quadratic equation. We need to fill in the blanks. Now, if solutions to this method of filling in the blanks don't pop up quickly, go straight to the quadratic formula. But let's see if we can do this. This is going to be 3x. This is going to be x. Now 200, it's tempting to put 20 and 10 here because we've got 20x here and 30x here, so 50. So these would have to be both negative to give us a negative 50x. The trouble with that is that negative 20 multiplied by negative 10 would give us positive 200. This isn't going to work. But if we put the 20 here and the 10 here, so let's have a look at the underneaths. We've got 10x here and 60x here. If we make this guy negative and this one positive, we will still get the negative 50x, but we will now get negative 200 from this multiplication. So the argument goes, if this equation is to be true, either this part is 0 or this part is 0. So that we can say that 3x plus 10 equals 0. Therefore, x equals, well, if you rearrange and then divide by 3, we get negative 10 divided by 3. Now, x cannot be negative, so we can reject this solution. It's an academic solution, but it's not a practical solution. Okay, let's try this one. We've got x minus 20 must equal 0. This happily produces a positive answer of x is equal to 20. Now, with that, we can pop 20 into the area and get that the area of the original playground is equal to 3 multiplied by 20 squared, which turns out to be, this is 400, 3 times 400, 1200, and this will be in meters squared. And that is your answer. Let me say again, if these solutions don't pop out really quickly, go straight to the quadratic formula with 3 as A, negative 50 as B, and negative 200 as C.